Hi guys, in this video I want to discuss the hidden technical debt in ML systems and how can actually MLOps help us solve this problem. There was a recent study where it was found out that the cost of bad code, meaning the technical debt, is huge. Not only in monetary sense, but the developer time spent dealing with these issues is a big part of their working hours. They spend a lot of time debugging, fixing, and thinking about bad code, meaning the technical debt that was generated with bad practices around the code repository. And the same thinking pattern can be actually translated to the machine engineering part, where you have the model and now you are thinking, what do I need to productionize this and bring it to customers and serve it. Basically what ML applications are about is the three dimensions of data, model, and code, and all these three dimensions interact with each other. So when the new data arrives, new model, new algorithm is trained, and the glue code around it is built or written down, that then again is used to deploy this model. Then when we notice in the production when the different model is needed, then we need to change the model or change the data. And this is basically the change anything, change everything principle. As long as one dimension of this is changed, this is going to have implications to all the other dimensions in our pipeline. How did this even come about? A brief history of evolution of MLOps shows us that right around 2018, 2017, it was noticed that even though has been a huge advancements in the number of data and the computing resources that we have, there were still some problems in actually productionizing these systems and serving them to the clients and bringing some real values. And that's where the terms of Dockerization of the ML stack, deployment on some cloud or Kubernetes, and providing some sort of manageability of the whole MLOps system. Remember, that's not only the model, the machine learning algorithm. We are talking also about the code that wraps the model and deploys it, and also the data. And they are all interacting together. And solution to this, and what has been coined into one big tent, so to say, is the MLOps, meaning the machine learning operations, where it's basically a try to apply the development operation DevOps principles to machine learning applications in order to reduce the technical debt, because these bad practices accumulate and the long-term price that we have to pay is not only monetary but also the development time and productivity that needs to be invested into those systems that were built badly from the scratch. Now, going into more detail and looking at this iterative incremental process in the MLOps, where we have the design, the model development, and the operations, and we see that in the design we talk about MLOps use cases, data availability checks, requirements engineering, meaning we are designing our initial machine learning system and seeing, does it even make sense to automate something? What do we even want to do? And is the data and the assumptions that we made around this data even true? And then after that, we can move to the right and build the model, develop it, meaning the data engineering, building the pipelines, ingesting it from the data source, building the models, and then test it and validate it to make sure that it actually serves a purpose in production. After that, we have the operations. Again, moving to the right, we see that we are talking about deployment, building up some CI/CD pipelines, and monitoring and triggering. Now, what this part should serve is basically making sure that after we have initially served the clients and deployed some of our models, that some of these steps are automated, meaning testing, the deployment, the monitoring of performance of our machine learning model in production, triggering some retraining or adjustments that are needed if there are some malfunctioning in our pipelines. More specifically, what this means is differentiating three levels of maturity for MLOps system. Level 1 is the manual process, so that would be the data science experiments, data analysis, model analysis, just validating the assumptions and seeing if we can actually bring some value with the machine learning. Then the level 2 is the ML pipeline automation. And what we understand at the level 2 of MLOps is basically process of retraining the model is automated. So as the new data is arriving, or there has been some difference in distribution of the data, covariate shift, the process of retraining a model is no longer needed to be done by the data scientist, but this is automatically triggered with certain indicators. And the level 3 is the CI/CD pipeline automation, meaning where we automatically build, test, and deploy the data, machine learning model, and the machine learning training pipeline components. And this is exactly the code, right? That these components and the glue code that wraps the model together, meaning the ingestion of the data, the deployment, all the necessary stuff to glue this together and actually serve a purpose for the task that we are trying to automate. This could be broadly summarized in 4 continuous terms: continuous integration, delivery, training, and monitoring. And some of these are already available and familiar for the DevOps practices, the CI/CD parts, where we are basically making sure that the testing and validating the code is done automatically, and the delivery and deployment of the pipeline of the code that we had in our software project is also automatically handled. But then specifically for the MLOps, we have the training and the monitoring, where the training is automatically triggering the pipeline to retrain the model, refit the parameters, and make it again smart, again adjusted to the new scenario. And the monitoring not only of the model, also of the data, of the code, of the whole system, if it's performing the way it should. And then depending on this monitoring, we would trigger based on different performance metric, different scenarios. Going a little bit deeper in one concrete example architecture, this machine learning operations can be done in an open source, in a hybrid, meaning cloud and open source, and the cloud environment. Here what you are looking at is the example AWS architecture of MLOps. And concretely, we are seeing that there are different AWS offerings that allow us to build such a system. Bundling these offerings together and making architecture, as you are seeing on this diagram, can fulfill the requirements that we specified previously, meaning the CI, CT, continuous monitoring, and then continuous training. If we start to look at this graph from the feature store, meaning from the left up corner, we see that there we are ingesting some data, and after we are ingesting it, we are pushing it to the model pipeline, meaning we have a AWS step functions where we can orchestrate different steps that need to extract, validate, and prepare the data. This data can be saved to a data pool, data lake, where then we can use Amazon SageMaker to train, and then step functions, AWS step functions to validate the outputs, meaning making sure that the outputs are actually serving a business purpose. Then after that, we can further pass that to the AWS SageMaker model inference, where we can make the predictions and make sure that they are actually deployed to an endpoint that serves a customer and automates a certain task. Then these obviously predictions can be monitored with AWS CloudWatch, seen in the middle down corner. So right in the middle down, the CloudWatch will be there to monitor model performance degradation, and depending on that, make some triggers. These triggers will then again start the retraining or reconfiguration of our pipelines, making it again more robust and stable for future scenarios. So this could obviously be a high-level overview of architecture that serves some purpose of automating and making scalable and robust machine learning application. But obviously a question remains, is there an open source variant of this, and why is the AWS solution the best? One possibility out there that's very famous is the Kubeflow pipelines, where we can basically achieve all or most of the things that SageMaker, the AWS SageMaker, can achieve just on the open source variant. And then if we are not satisfied with using completely open source solution, we can integrate it into the SageMaker capabilities, so still making it independent of the platform, but then again utilizing some of the specific software solutions that the AWS proposes. And then finally, if we were to talk about the pricing and how do different open source or cloud native or hybrid MLOps solutions compare with each other, there are definitely a clear-cut positives and negative for both, meaning if we choose the open source variant, then we are actually opting for multi-cloud solution where we can switch from different cloud companies and cloud solutions, and we would have more flexibility in configuring our machine learning pipelines and our machine learning operations solution. What are the pros of the cloud native is that we don't have as much maintenance, meaning there's a lot of off-the-shelf solutions like, as you saw, AWS SageMaker. A lot of stuff are already pre-programmed in there, and there is a lot less complexity to deal about. Again, what you see in this table here with the overall summary is actually a comparison of possible solutions to MLOps in the AWS, where we were to talk about how to build a machine learning platform for data scientists on the AWS, where they don't only fulfill the continuous requirements, but also training, deployment, retraining, experimentation, wishes of the data scientist. And there we see that SageMaker, compared to the EC2 instances, compared to the EKS, the Kubernetes service, is a lot cheaper when looking the long-term perspective. It's just more cost-effective variant to deploy end-to-end MLOps solution to the AWS and leverage what is already built into AWS SageMaker. What's very important to note, finally, as a conclusion to this clip, is that there is not one solution that is always superior to others. For example, if you really don't want to lock into one certain cloud, it would be maybe smarter to opt for the open source variants. As I already said, we have the Kubeflow that offers some of the machine learning operations MLOps requirements and can tackle and solve these problems. MLflow for data versioning. There are also some other different open source solutions out there. So there is no one tool that beats them all. Rather, one should evaluate the pros and cons of different solutions and then, depending on that, implement them. But they should all satisfy the previous requirements that we posed and that we want to actually satisfy for the MLOps. So the 4 C's, as we already discussed, and finally the 3 levels of automation. The manual process where we build the machine learning stuff, where we build the glue code and prepare the data for the machine learning models. Then we do level 2 automation, meaning some of the pipelines are automated, like retraining, fitting, etc., etc. And then level 3, where basically most of the stuff is automated. We don't have to think in an online fashion. We don't have to think about deployment. We don't have to think about testing and